On this problem, we're talking about proportions. So it tells us we have a simple random sample of 85 students. So we have n equals 85. And we want to estimate the proportion of parents who bought them a car when an interview of 51 said their parents bought them a car. So when we look at the number of people who said yes to the question, we usually just call that x. So there are 51 people that said yes. 51 people said yes. What is a 95% confidence interval for P, which would be the proportion of students at the university whose parents bought them a car when they left for college? So when you hear that, you know we're talking about proportions. So let's switch over and look at our guided notes for proportions. So for proportions, we have here, let's see, we went through a little bit of work. We have things like our sample proportion, p hat is equal to x, which is the number of successes over n. And we have, you have an approximate confidence interval we could do. So it would be p hat plus or minus z star, which is the critical value, times the square root of p hat times 1 minus p hat over n. Now you can use this, but you don't have to. You could just go through and actually use your calculator. So to use our calculator, basically we do just need to check first that our sample size is large enough, and we can either check that with our sample proportion if that's what we're given, or we can check with our number of successes and number of failures. Once you've checked that, all you have to do is put it into your calculator. So I don't know which calculator you have, but if you have the TI, you would go to Stat, Test, and you're looking for 1 proportion z interval. So you're just basically looking for a 1 proportion z interval. And that's going to have you enter x, which is the number of successes, instead of p hat. So in our case, you're going to go find that z interval, and really all you have to put in is that we want, let's see, 95% confidence interval. So you'd have to make sure you put in the 95% or 0.95. And you're going to have to make sure you put in the x equals, let's see, what do we say? 51 people and 85 students. So x is going to be 51 and n is going to be 85. And when I do that, I get that my interval goes from 0.4958 to 0.7041. So that's the interval I get. Again, all I had to do is find the 1 proportion z interval in my calculator, do 0.95 for the level, x is 51, n is 85. And I get my confidence interval. Now, if you wanted to do it by hand, okay, oh, and to check my number of successes, I had, let's see, my success was 51, which means my failure, or people that said no, would have been a total of 85 minus 51, which is 34. So 51 is at least 10, 34 is at least 10. So we're good, we can use this interval and the calculator. Now, if you wanted to do it by hand, the first step by doing things by hand is to find p hat. It's the number of people who said yes out of this total. So 51 out of 85 gives me 0.6. So our formula, well, first we have to check, is n times p at least 10, and n times 1 minus p at least 10. So let's check that. N is 85. So 85, sorry, we're checking n times p hat and 1 minus p hat. So 85 times 0.6 gives me 51. And 85 times 1 minus 0.6 gives me 34. Notice these are the same numbers we got when we just checked the number of successes and number of failures, because n times p hat is the number of successes and n times 1 minus p hat is the number of failures. So these are at least 10, so we can use them. So to find our confidence interval, you will need to know z star. So we want a 95% confidence interval, so that means we want 0.95 in the middle, and we want to find z star. Well, this is a z confidence interval. So you're going to use the inverse normal function on your calculator, and you want 0.95 in the middle. Now, if you don't have a calculator that lets you do 0.95 area in the middle, you could say, well, if it's 0.95 in the middle, that means 0.05 for each tail, or 0.025 here, 0.025 here. So you could tell it, I want 0.025 to the left, and it'll tell you this value right here, and then you can figure out what z star is. So I put that in my calculator, and I get z star equals 1.96. Now we can plug it into our formula, which is, the constant rule will be p hat plus or minus z star times the square root of p hat times 1 minus p hat over n. So we're going at 0.6 plus or minus our z star, which is 1.96, times the square root of 0.6 times 1 minus 0.6 over n, which is 85, which gives me 0.4958 to 0.7041, which should be the same thing I got when I did it on the calculator, which it is.